So welcome to the 10th lecture of this course, and the name I'll give to this lecture is shortcut. Shortcut, or a short method you can say, to find the r's complement and r minus 1's complement of a given number. Now before I come to this, what I discussed in the last lecture with you, in the last lecture I discussed that if there is a number n, with base r, you have two types of complement. One is called the r's complement. C stands for complement for the time being. So I told you that this is equal to r to the power n minus n base r, where n is the number, r is the radix or the base of the number, and n is the number of digits in the integer part. Suppose I say that you have a number 526.43. Suppose there is a number in base, say 7 here. So with respect to this definition, the value of n is 3. That is, there are total 3 digits in the integer part. There are 3 digits in the integer part, and in the fractional part you have 2 digits, and the value of r means base, value of r is 7 here, and of course the number is this, n, value of n is 526.43. I hope this, I am repeating this definition. And the second definition that we said is for this number with base r can have another type of complement, that is called r minus 1's complement. R minus 1's complement, it is given by r to the power n minus the number n with base r, and one more term I add here, simply it is r to the power minus m. Same definition, and one more term, that is r to the power minus m, where m is the number of digits in the fractional part. For example, suppose I say in this particular example only, value of n is same, value of capital N is same, value of small n of course 3 digit, but the value of the number of digits in the fractional part, or the value of m in this case, is 2 digits. So you can say that the value of m is equal to 2. I hope that this is clear to you. Now suppose I say, let's take an example. I'll leave some space for writing what are the rules for shortcut. So I'll start from here. Suppose I say, I give an example here. Suppose let's take an example. Suppose I say that I have a number 456 in base 8, and I say that find its it can have 2 complements, 7 complement, it can have 8's complement as r's complement, and r minus 1's complement is 7's complement. And suppose I say that I am interested in its 7's complement. Just see, I am interested in its 7's complement. So the 7's complement of this, look at this, what is the problem with respect to this definition? With respect to this definition, if you see that the value of r is 8, in this case the value of r will be 8. The number is this much. Number of digits in the integer part is 3. Number of digits in the fractional part is 0. So I am interested, 7's complement means r minus 1's complement. If you see from here, 7's complement means r minus 1's complement, and if I apply this here, r to the power n, r is 8, so I can say 8 to the power 3, r to the power n, minus r to the power minus m, minus 8 to the power, you can say it is minus 0 plus 0, 1 upon 8 to the power 1, r to the power n, minus the number n. What is the number? That is 456 with base 8. So I have applied this formula using r minus 1's complement. With base 8, 7's complement means 8 minus 1, that is r minus 1's complement. And now let me solve this problem. What will be the result of this? So if I find this, this is equal to 8 cube. 8 cube results in 512 minus 1. Remember that this 512 is in base 10. This one, of course, in base 10 or in base 8, it is same. Let's take it as base 10 only. Minus 456 in base 8. I hope that this is clear to you. This is, if I solve this, this results in 511. 512 minus 1 is 511 in base 10 minus 456 in base 8. Now this subtraction is not possible because the two bases are different. I told you that very first thing is that you have to convert this into a same base. So what I do, I convert this 511, I simply convert this 511 into base 8 because the 7's complement of base 8 will be the resulting number will be in base 8. So I want the final answer in base 8 actually. So what I do, I convert this 511, just see what I am doing. I am converting this 511 base 10 into base 8. So what I do, I divide this by 8. Okay, so 8 6 are 48, remainder is 3, 31, 8 3 are 24 and 7 is 31. Then 8 7 are 56 and the resulting number is 7. Balance is 7. I started from here and move in this direction. The 7 is less than 8, so I stop it here. So the final result is 777. Okay, luckily it is 777. So this results, it means I can say that this is 777 in base 8. 510 is converted into base 8 and this minus 456 in base 8. I hope that this is clear to you. And now if I find the result of this, 7 minus 6 is 1, 7 minus 5 is 2 and 7 minus 4 is 3. So this results in 3, 2, 1. This is my final answer in base 8. It means that the 7's complement of this number, the 7's complement of this number is equal to this much. This is my answer at this stage. And suppose I say that what is 8's complement, you can find the 8's complement also in the same example. In the same example, suppose I say that what is this number 456 in base 8. What is its 8's complement? Suppose I say 8's complement of this. 8c means 8's complement of this. Of course, it is the same formula here. If you see, it is the same formula, r to the power n minus r to the power minus m and this much. R to the power minus m is not there, it is same thing. It means this one is not here, and if I do the calculation, this factor will be 3, 2, 2. You can find it. You can cross check it by applying the formula also. So I hope that this is clear to you. Let's take one more example. Suppose another example. Let's take an hexadecimal number here. Suppose I say, let's take an example, hexadecimal. I say that you have a number which is say 6e. This is in base 16. This number is in base 16 and say that I say that find the 15's complement of this. Find the 15's complement, and of course 16 complement also will find. So let's find out the 15's complement, 15 apostrophe s and c for complement. I say find the 15's complement of this. Again, now look at this. 15's complement means it is r minus 1's complement. When I say r minus 1's complement, it means if I apply this formula, r to the power n minus r to the power minus m minus the number. So value of n is how much? It is 2. Number of digits in the integer part. Intentionally I am not taking for the fractional part for simplicity. Otherwise there can be a fractional part also. So with respect to this problem, if you see that the value of n, again here, value of n is 2 in this particular problem. In this problem I can say that the value of n is 2. Value of m is 0 And of course the number n with base r, in this formula the number n with base r is 6e with base 16. I hope this is clear to you. Now if I apply this formula here, so you have this r to the power n is 16 to the power 2. This r to the power n, what I am applying here is this r to the power n, and r to the power minus m means 16 to the power minus 0, minus 16 to the power minus 0 or plus 0, and minus the number means 6e. This is the number in base 16. Now if I solve this, 16 into 16 is 256. 256 minus 1 minus 6e in base 16, and this is 255, but this is 255 in base 10 minus 6e in base 16. I hope this is clear to you. Now if I again, this 255 is in base 10, so I'll have to convert this 255 into base 16. So what I do, I divide this 255 again. I divide this 255 by 16. It will be 15 and remainder will be 15. I have done the calculations already to save the time. This is 15 and this is 15. Now this 15 corresponds to f in hexadecimal, and this 15 also corresponds to f here. So from here I write this in the reverse order. I am writing this in the reverse order. So my final this means it is equal to f minus 6e, and so the final result f minus 6e. F means 15, e means 14. 15 minus 14 is 1. This 15 minus 14 is 1, and this f is 15, and 15 minus 6 is 9. So this is the corresponding number, or this is the corresponding 15th complement of this particular number. And similarly you can have this number. Let's take the 6e, same number. If I say what is its 16th complement, the 16th complement of this, I'll add simply 1 here, it will be 92. You can cross check it. You apply the formula, this will not be there, so it will be 255 minus this factor, rather 256 minus this factor. Find the corresponding hexadecimal of 256 minus this, that this results in 92. So by formula, how you have to calculate, by applying the definition or by applying the mathematical definition of r's complement or r minus 1's complement of any number. So this is by formula I told you. Now what I started with is with a shortcut. There is a shortcut to find this, to find the r's complement or r minus 1's complement. Suppose I say that you have a number 75632 in base 8, and I say that find its 7th complement. Find its 7th complement. So what simply you do is that you subtract every digit from 7. You subtract every digit from 7. So 7 minus 2 is 5. This is 5. 7 minus 3 is 4. 7 minus 6 is 1. And 7 minus 5 is 2. And 7 minus 7 is 0. This is the 7th complement. And in order to find its 8th complement, the same number, suppose I say that what is its 8th complement? In 8th complement, you add 1 to the rightmost digit, not to the number, but to the rightmost digit. What do I mean by this? I'll just tell you. You add 1, so it will be 2, 1, 4, 5, 6. This is the 8th complement. Similarly, suppose I say that you have a number. Suppose I say that you have a number 563.46 in base 8, and I say that what is its 7th complement. First, what is its 7's complement. So the 7's complement of this 7c. 7's complement means subtract every digit from 7. So 7 minus 5 will be 2, 7 minus 6 is 1, 7 minus 3 is 4, 7 minus 4 is 3 point. Of course, 7 minus 4 is 3 and 7 minus 6 is 1. This is the 7's complement of this base 8 number. And if I say that what is 8's complement, means this is r minus 1's complement and this is r's complement. So its complement will be, you simply add to the rightmost digit. In many books it is written add 1 to the number. No, adding 1 to the number will be 215.31. So add 1 to the rightmost digit. So it will be 214.32. This is your 7's complement and 8's complement. Now let's see what we have done. Is it satisfying here? I said that find the 7's complement of 4, 5, 6. So what you do, simply in spite of going for all this formula, in spite of going for all these calculations, what I do, I simply subtract every digit from 7. So 7 minus 4 is 3, 7 minus 5 is 2 and 7 minus 6 is 1. It is as simple as it is. That is, you can apply this shortcut here. Similarly, suppose I say that you have a hexadecimal number. Suppose I say that you have a hexadecimal number and suppose I say that you have a number 6AEC point D3 in base 16. I say find its 15th complement. 15th complement of this number. Now how to find the 15th complement of this number? Just see what I do. I subtract every digit from 15. Alright. So 15 minus 6 is 9. 10 is A. 10 is A. A is 10. 15 minus 10 is 5. E is 14. 15 minus, I am doing what? I am subtracting every digit from 15. Just see, 15 minus this, 15 minus this, 15 minus this, 15 minus this and 15 minus this. So 9, 5, then this corresponds to 14. 15 minus 14 is 1. Then C, C is 12. 15 minus 12 is 3. Point. D is 13. 2. 15 minus 13 is 2. And 15 minus 3 is 12. 15 minus 3 is 12 and 12 corresponds to C. This is the 15th complement. And if I say that what is 16th complement of this, I'll simply add 1 year. When I add 1 year, it will be 9513.2 C plus 1. C is 12, 12 plus 1 is 13 and 13 corresponds to D. I hope that this is clear to you up to this point. Now let's cross check this, whether this is verified here or not. Just see, the verification of this is 6E. I said 15th complement of this. So what I do, this is my answer. I subtract every digit from 15. So 15 minus 6 is 9 and 15 minus 14 is 1. And I add 1 to this number. So I hope it is clear to you. So just to write the shortcut, let me write down the bullet point of this shortcut what we have done till now. That first of all, if you have any number n with base r and if we are interested in r minus 1's complement of this number, if you are interested in r minus 1's complement, the shortcut is subtract every digit, subtract every digit of the given number, that is n base r, from r minus 1. From r minus 1. I hope this is clear to you. And in order to find, if you have a number n base r, if you have to find r's complement, it says add plus 1 to the rightmost digit. I am writing only RMD. RMD of r minus 1's complement. Of r minus 1's complement. I hope this is clear to you. Okay, since the light is getting dim, so I'll stop it here and I'll continue how to do subtraction, the application of these complements in the next lecture. So thank you for the time being.